we were assigned specifically to a topic called Dirichlet Robin non-homogeneous equation. The Dirichlet Robin non-homogeneous equation is a part of partial differential equation. It is also known as PDE. Generally, PDE is a differential equation that contains partial derivatives of the dependent variable, one or more, with more than one independent variable. A PDE with u as the dependent variable and x, y, z, and t as the independent variables may be written in this form. The Dirichlet Robin equation is actually one of the heat equations. In order to find the heat equation, we need to satisfy both conditions, boundary condition and initial condition. Boundary condition is a condition that must be met at places along the spatial region's boundary where the PDE holds. Meanwhile, the initial condition is a criteria that must be met across the solution domain at the time when the physical model is considered. Now, let's move to the question given. Firstly, the existence of 2x as qx represents the non-homogeneous equation. Therefore, this shows that it is a non-homogeneous partial differential equation. Second, this is the first boundary condition, which is Dirichlet condition. The third one is the second boundary condition, which is Robin, since there is an addition of Dirichlet and Newman. Not to forget that there is 3 here which represent the H value, which act as a convection. And the last one is the initial condition. We need to satisfy these 3 conditions in order to obtain the heat equation U x T.
It is important to note that this cannot be solved by separation of variables method or simply called SOV. So what we do here, either we use one of the 2 methods for solving nonlinear PDE, which are decomposition method and eigenfunction expansion. This working, we're going to apply the first method, which is decomposition method. By using decomposition method, our aim is to get rid of the non-homogeneous part, resulting in a new model of homogeneous PDE. We begin our working by let uxt is equal to vxt plus wx. Next in the line, we differentiate it with respect to t to obtain utxt with respect to s to earn usxt, and we differentiate again usxt that we have again in order to get ussxt. Following the assumptions, we then substitute into our PDE before, which is utxt is equal to ussxt plus 2s. Afterwards, we separate the equation to PDE equation and ODE equation, and that is when we achieve VTxt is equal to VSSxt. For our first equation, PDE equation, we name as A, and W double prime is equal to negative 2s for the second equation, B. After that, we substitute it into our VC1 and VC2, which is U0t equal to 0 and US1t plus 3U1t equal to 0 respectively. The same step is applied where the equation was separated to 2 equations, PDE and ODE. At this point, we actually accomplished to derive new boundary condition for both our PDE and ODE model. From VC1, we obtain V0t equal to 0 as first boundary condition for PDE model, while W0 equal to 0 as first boundary condition to ODE model. As for VC2 substitution, the second boundary condition for PDE and ODE are named as 1b and 2b respectively. Unlike VC1 and VC2 substitution into IC only produce an equation for PDE labeled as 1c. For a more clear understanding, I'd love to explain that if you happen to wonder why it has to be WS instead of WST, WS is said to be ODE and VST is said to be PDE because WS has only one variable, while PDE contains 2 variables. Alright, now as our aim is to make the non-homogeneous PDE to homogeneous PDE, we actually give the non-homogeneous part to ODE model. However, as we go through, first, we integrate the equation both sides to get WS. Once WS is well defined, the boundary condition 1 and 2 was substituted into the equation to find the value of constant A and constant B. At the end, WS is equal to negative x cubed over 3 plus 1 over 2x. Okay, since we already have WS, we can now turn the initial condition in PDE model, which Vs0 equal to S minus Ws, by replacing Ws with the answer that we get previously. Given that now new PDE is homogeneous, we can proceed our working in finding UXT by solving the new PDE by finding VXT. So what is our VXT? By looking at our new model, VC1 shows us that there is a heat loss from the right into the medium held at temperature of 0 degree, which means Dirichlet, while the second boundary condition shows that there is a heat flow from the right side according to the Newton law of cooling. The heat transfer coefficient H equal to 3, where it means the equation is mixed set boundary condition and Newman plus Dirichlet. With Dirichlet as boundary condition 1 and mixed set boundary condition n plus d in BC2, we now know that this is a homogeneous equation of Dirichlet Robin. Considering that in decomposition method, we can simply take the eigenvalue and eigenfunction that we have learned before. So, Vxt is equal to summation of n times sine zn x times exponential to the power of negative zn squared t. By referring our new PDE, substitute the Vxt with Vx0. Here we get n is equal to integration of s from 0 to 1 fs, which is s cubed over 3 plus 1 over 2s times sine zn x dx, divided by integration of s from 0 to 1 sine square zn x dx. Next, from this, we're going to simply solve the n in order to obtain Vxt. Once we got Vxt, do remember our assumptions at the very first step when we let Uxt equal to Vxt plus Wx. Finally, our Uxt is solved.